So hello everyone, here is another problem on basics of working principle of induction motor. So there were a series of videos on explaining theory behind working of induction motor, but then now we are quickly solving some basic problems. Okay, so let's look at the example. The question is on your screen right now. This is example 34.3 from the book on electrical technology. The information about the book I'll leave it in the description. Okay, so let's look at the problem itself. A 4-pole 3-phase induction motor operates from a 50 Hz supply. Calculate speed at which the magnetic field of the stator is rotating. So this is straightforward. Uh, Basically, the synchronous speed is what is being asked in the question. So synchronous speed, as you know, the famous formula 120 F by P. So 120 into frequency is 50 and the number of poles is 4. This information is given in the question. It's a 4-pole and the frequency is 50. It's given in the question. Okay, so what is this value? I think 4 goes 30 times. This is 1500 RPM. Okay, now the speed of the rotor when the slip is 0.04. Okay, so when the slip is 0.04, what is NR? So we know that S is nothing but Ns minus Nr by Ns into 100. Here I am not putting 100 because slip is given 0.04. So to know the rotor speed, I can simply calculate from it because Ns is known and S is known. So what do I get? 0.04 equal to 1500 minus Nr divided by 1500. So from this I can calculate what is Nr. So let's do that quickly. So 0.04 multiplied by 1500. So I multiplied this here, I get 60, and from that I subtract 1500. So minus 1440 is nothing but minus Nr. So minus cancels. So I get 1440 RPM. So you see, although the synchronous, the speed at which the magnetic field is rotating at 1500, the machine itself is rotating slightly slower at 1440 RPM, which is at the 4% slip, which is typically the full load slip. Okay. So let's look at the other question. The frequency of the rotor current when the slip is 3%. So we know that the frequency of the rotor Fr is nothing but S into Fs. So 0.03 multiplied by 50 Hertz. So how much is this? 0.03 multiplied by 50. So I get 1.5 Hertz. So the EMF which is induced in the rotor actually having is a AC EMF, but the frequency is very low, it is 1.5 Hertz. Okay. And the last question, frequency of the rotor currents at standstill. Now at standstill, Nr equal to 0, so therefore the slip is 1, okay, or 100%. Therefore the answer to this is again 50 Hertz. The Fr will be equal to Fs because slip is 1. Okay. So I think this is the quick problem with 4 questions, and then we try to solve all of them, and this is the problem. Let's extend the question. Repeat the problem with poles equal to 6. So what happens if there are 6 poles? Let's quickly do it. So how do you find Ns? 120 F by P. So 120 into 50 divided by 6. Okay, so let's do that. 120 into 50 divided by 6. So we get 1000 RPM. So immediately you see as the number of poles increases, the synchronous speed decreases. So this is the inverse relation between the synchronous speed and the number of poles of the machine. Therefore, the high speed machines will have less number of poles and the low speed machines will have high number of poles. So that is the thing that we learn from this. Okay, this was the part A. What is part B? Speed of the rotor when the slip is 4%. Okay, so when the slip is 4%, what is Nr? So again I just do the same calculation. So 0.04 equal to 1000 minus Nr divided by 1000. So 0.04 into 1000, sorry, 0.04 into 1000, I get 40 RPM, and from this I subtract 1000, I get 960 RPM. So that is the rotor speed will be 960, slightly less than the stator speed. The frequency of the rotor current when the slip is 3%. Now this has nothing to do with the synchronous speed itself. So frequency of the rotor is slip into frequency of the stator. So 3%, so 0.03 into 50. So the answer is still 1.5 Hertz. There is no change here. Similarly, the frequency of the rotor currents at standstill also there is no change. So the answer to part D is also 50 Hertz at standstill. Alright, very quickly repeat the problem with P equal to 6 and frequency is 60 Hertz. Now we'll see what is the effect of increasing the frequency. So what is synchronous speed? Synchronous speed is 120 F by P. So 120 into 60 divided by 6. So this will be 1200 RPM. So now you notice by increasing the frequency I have increased the synchronous speed. Earlier it was 1000, now it is 1200 RPM. Okay. What about the other questions? The NR. So at 4% slip, so 4% of 1200 is nothing but 4 into 12, that is 48 RPM. Now if I subtract that, 1200 minus 48, so by the way this 48 RPM is called slip speed. Okay, so 1200 minus 48, I get 1152 RPM. So this is the answer to the second question. And answer to the third part, FR is nothing but S into FS. So 3% slip into 60, I get 1.8 Hertz, slightly higher frequency. And then finally the FR equal to FS at standstill. So which is nothing but 60 Hertz. Okay. I think very quickly we solved this problem. So I hope you understand it. There is nothing complicated. Everything is straightforward. Just the application of these two equations. That is equation of the synchronous speed and the equation of the slip. Okay. With this, I'll end this video and we'll see more.